Hello, Peter here. This is part 2 of how to create blob shadows in Unreal Engine 4. Last time I showed you how to use the inbuilt spherical mask in combination with the world position behind translucency function. Today we are going to exchange the sphere mask with our own material function to create an ellipsoid opacity mask for our blob shadows. To make things a bit clearer, I increased the intensity of my directional light in my level so that we can see the shadows much better. Also, I made sure that the sphere we created last time is actually set to movable, because if it is static it might still cast some shadows. The setting for it in lighting is that it will cast a shadow, but because the directional light is static, it will not. Okay, let's get started. We already created last time a folder called SDL, which will contain the whole package. In there we have a folder called Materials, where we created our blob shadow material. Now there we are going to create a new folder, and we call that one Functions. Open that folder. And here we're going to create a material function by right-clicking, selecting Materials and Textures, Material Function. I'm going to name this function mf underscore ellipsoid mask. And now we can open this new function in the material editor. First, some boring stuff, namely math. In our material function, we are going to implement the equation of an ellipsoid. Now the equations assume that the ellipsoid is axis aligned. However, I did add offsets for all directions, so we can offset the shadow from the center. Offsetting in the z direction has no practical value for us. That is why we are going to use the second equation. What has enormous practical value for us is the ability to cut off the ellipsoid at a certain value of z. In that way we can prevent the shadow being projected onto the object. As you can see, we simply change the z value to be outside of the ellipsoid if the z value is more than the cutoff value. Note that the z's inside the ellipsoid extends from minus radius z to plus radius z. So by adding 1 to radius z, we are pretty sure it's outside the ellipsoid. When all is calculated, we simply output 1 for all points inside the equation adjusted for the cutoff. Everything else is 0. Okay, well, I hope you didn't fall in a coma because of that. Now we're going to do more interesting stuff, is implementing it. Our material function needs a bunch of inputs, so we're going to create them first. We need a bit of space here. The very first one is a vector input. And we are going to call that one, it is the position, but it's the world position behind translucency object position, just to make it more interesting looking. The type for that one is it is a vector 3. We can leave all the values to 0. So that is 1. The next one is a scalar, and that is radius x. And the type for that one we have to set to scalar. Now set the sort priority to 1 for this one. Now we can, with Ctrl W, duplicate this one, because we need a bunch of scalars. This one we are going to call offset x. All the values can be 0, but the sort priority is now 2. Let's put it down, by the way. And let's duplicate another one. And that one is going to be called radius y. Sort order 3. Duplicate it. And that is going to be offset y. Sort order 4. And duplicate that one. And I guess you know what is coming here. It's going to be radius z. And that one has sort order 5. And duplicate it. And this one is going to be called the cutoff z, because we don't need an offset for the z here. This one has sort priority 6. Now here we have the 3 parts of our equation. Now we have to implement it. So this here, the position is a vector, but we will need to have the separate components. So we're going to create a mask, a component mask, and in the details panel make sure that only the R is selected. That's going to be the X. Now these two here, we're going to move somewhere here nicely, because what we need to do, if you remember the equation, is to subtract the offset and then divide that by the radius. And then this result needs to be squared. Now I'm going to do that with multiply and just connecting A and B with the same. There's a funny story attached to that because I first implemented this package using Unreal Engine 4.13, and then I used the power node here with an exponent 2. For some reason, when I took that into 4.18, it didn't work. I have no idea why. But okay, this is one part of the equation done. Now I need to do the same thing for the y. Let's just skip that and do a jump cut where I've done that. So I'm back. I have done the y component of the equation now and made a bit of space, because now we are going to do the z bit, or z. I never know if it's z or z. Let's mask out only the z component. And if you remember the equation, we need to add the z component and the radius. And then we needed to test something. So if put it here. So if the z plus the radius was bigger than the cutoff, we needed to make sure it's outside of the ellipsoid. And we're doing that simply by taking the radius and add 1 to it. We can simply do that by making sure that constant b is 1. So this if node will output if a is greater than b, this one, if a equals b, that one, and if e is less than b, this one. So this one is going for if a is greater than b. For the other two options, we simply use the z as is. See if we can make this look a bit nicer. So, right. So this is our adjusted z. It's either the normal z or the z adjusted for the cutoff. So now we simply have to divide that by the radius, because we do not correct it for an offset. And then square it by using the multiply node. Like so. Now we have all three parts, the x, y, and the z part of the equation done. We only need to add them together. So this is add these two parts. And here we're going to add these. So that is our calculation of the equation done. Now we only need to test this result and see if it is inside the ellipsoid. So if a is greater than b, and we are going to set b to 0, to 1, sorry, then this b will simply be a constant 0. Oh, sorry, no, of course, but I mean if a is greater than b and b being 1, we return 0. In all the other cases, we also create a constant, and that is going to be 1. And we need to return that both for equal and for less than. Now we can get our output in the neighborhood and connect them up. So this is our function done for now. So let's save this one and close the material editor window. Okay, now let's return to our material, the Blob shadow material. Open it in the material editor window. And here you still see our old attempt with the sphere mask. We can simply delete that one. We're going to need some new parameters. So create a scalar parameter and call that one radius x. Set the default value to 50. Now duplicate that one and rename that one to radius y. Also leave the default value at 50. Duplicate that one and name it radius Z. Also leaving it at 50. And then the last one, rename this one to cutoff Z. Set the default value of this one to 100. Now let's get our function in. Type function, and you will see material function call. In the details panel you can now select the ellipsoid mask function. And if you did all the sort priorities alright, you will have the same order, but if you have different order it doesn't matter. More important is that you have them all. Now the position we connect like that, and then we connect all the radiuses. Radius X, radius Y, radius Z, and the cutoff. Now we have the offsets left, but we set them to 0. So create a constant and connect them both. Now the output of this function we connect to the opacity input of the material. Save this material and let's have a look. Well, nothing changed. Well, that's a very good sign, because now we have basically the same functionality as the sphere mask did. All the radiuses were equal, which means it becomes a sphere, and the cutoff was at 100. That means that nothing of the sphere is actually cut off. Now let's remove this black from this sphere by doing a cutoff. And we do that by changing the value of cutoff, Z, and instead of 100 make it 56. That would be just 6 units above the ground. Save this. And let's see what happened. It is gone. If we now slowly drag on this, we still see the sphere, but we see that it suddenly gets cut off. There, see? This is where the cutoff Z is, which enabled us to remove the black stuff from the sphere itself. Now let us try to make the shadow disappear less quickly when the ball moves upward in the Z direction. First of all, we need to make sure that our cube is large enough, because it's now actually a cube. So let's increase the scale on the Z-axis so that we have more of a rectangular shape there. Now change the radius C to 100. So now the total ellipsoid will be 200 high. But then again, we're going to change the cutoff to say 106. Save this. And let's see a bit better what happens now. Let's select our sphere instead and start dragging on it. We will see it is much more elongated. And there still is that cutoff at half of the cigar-shaped form. But it is now much longer. So in more practical terms, that means you have to jump higher to really lose the shadow. For one last thing we can do, just because it's fun, is to change the radius of X. Make that, for instance, 30. Let's save that and see what that does. Well, quite clearly it made the shadow an ellipse on the floor, because now the radius of the X is less than the radius in the Y direction. So this is very handy when you, for instance, would use this type of shadow for a humanoid figure, or humanoid character. Now there are some things we haven't done yet. The hardness, and that we are going to do in the next episode, but also something else that has to do with this. Because you will notice that when I just select the cube and I would rotate this one, the shadow does not rotate with it. It is always axis aligned. And what we would like to have is when the player is moving or the object is moving and rotating about, that if we have a elliptical shadow, that we can make it so that that shadow rotates and keeps its orientation correct in relation to the object that casts the shadow. So both rotation and implementing the hardness will be the subject of the next episode of how to create blob shadows. So go ahead and experiment with this, and I will see you in the next episode. Bye bye. Hello, Peter here again. Just wanted to say thanks for watching this video. Please let me know what you thought of it in the comments. Below there are links to other episodes in the series, and don't forget to subscribe so you are the first to know when the next episode is up. Thanks again for watching, and see you in the next video. Bye!